without further ado, I'll introduce one of my colleagues from a Guam Sea Grant. Dr. Austin Shelton is a marine and environmental scientist, and he serves as an assistant professor and the director of the University of Guam Center for Island Sustainability and Sea Grant. Dr. Shelton is an Obama leader, Micronesia Conservation Coalition tide changer in education, and one of 50 under 40 emerging leaders in the government of Guam. Dr. Shelton established the Guam Restoration of Watersheds GROW initiative to revive island watersheds and downstream coral reefs. He also advances the 17 United Nations Sustainable Development Goals, and together with the Office of the Governor of Guam, Dr. Shelton co-chairs Guam Green Growth, the island's most comprehensive public-private partnership ever created to achieve a sustainable, equitable, and prosperous future. So without further ado, we'll let Dr. Shelton present. Thank you very much.
Thanks very much, Mike, and thanks for inviting me to participate in your webinar today. It's great to be speaking to people in Hawaii again. I lived there for about 12 years, went to Hawaii Pacific University for undergrad, and I was at the Kewalo Marine Laboratory for my graduate work. And I've been back home here in Guam for several years now. I think I moved back in 2015, but do enjoy going back to Hawaii quite often, well, before the pandemic, and seeing my friends there at Sea Grant and Hawaii EPSCoR. So thank you very much for signing in today on Zoom. And if I'm going to put my presentation directly in my video here, I'm not going to share screen, so it will most likely look best if you keep your view on speaker view. So I'll get started. Today, this afternoon, Hawaii time, I will be speaking about our Guam Restoration of Watersheds initiative that has been going on for several years now here in Guam. And it's a strong partnership between several entities. The core entities are the University of Guam Center for Island Sustainability, or University of Guam Sea Grant program, and also the Guam EPSCoR program funded by the National Science Foundation. So I grew up right next to the beach in Guam, and in a village called Asin. And when I would go swimming or fishing out in my backyard, I remember lots of the coral reefs looking beautiful and vibrant like this. But over time, they started becoming ugly. They were dying, getting covered with sediment and algae. And that's what inspired me to go to college to study marine biology and environmental sciences to try to figure out how to fix these problems and to find out what was going on. And so I found out later on that we had a problem with erosion. There were a lot of our bays, especially on the southern half of our island, that would look normal and beautiful on a regular sunny day, but after a big rain event, it would turn into the chocolate milk color, with thousands of tons every year of sediment washing into the bays, where they could cover, smother, choke our coral reefs. So that's what it looks like if you take a peek, put your head under the water in a few places close to the shore. There's quite a bit of sediment that you can kick up pretty easily right there. So this is bad for our coral reefs because it smothers them, or it blocks out sunlight, and they're unable to produce energy through photosynthesis with their zooxanthellae. And another big issue that we have in Guam that some people don't always realize is that it actually affects drinking water for quite a few people in the south, where a lot of the water production comes out of a river. So you can see that metal box there is an intake for one of the drinking water treatment plants, and it gets pumped up the hill, where it has to go through a 5-step process of things like flocculation and filtration. They have to make sure that the sediment all falls out. But when there is heavy erosion in the rivers, they actually have to shut down people's water. Like when there is the most rain and it seems like there's the most water available, it's a little counterintuitive that your water gets shut off on your faucets because there's just too much debris in that metal box and they're unable to clean it. So it affects, if you don't really care about the ocean or taking a look under the water, it will affect you in your house, in your water pipes. So I would like to share a little bit about our Guam Restoration of Watersheds initiative and what we're doing to solve some of these issues, or at least to contribute to solutions. I'll have a few parts to my presentation today. I'll speak about this overarching big picture thing that we have going on called Guam Green Growth and the UN Sustainable Development Goals. And then I'll talk about the 4 phases of the Guam Restoration of Watersheds initiative, and finally some of the community outreach and capacity building work that we're doing. So this is the center that is coordinating a lot of the work going on. Our University of Guam Center for Island Sustainability was established in 2009, and it's our mission to lead and support the transition of our island region toward a sustainable future. And our University of Guam Sea Grant program is one of our primary programs within our Center for Island Sustainability. In 2019, we in Guam adopted the United Nations Sustainable Development Goals, and this was through a strong partnership with Hawaii Green Growth, which I imagine quite a few of you would be familiar with there in Hawaii. We work closely with Celeste Connors and other partners where we have learned to develop programs to advance the UN Sustainable Development Goals in locally and culturally relevant ways. So this is now an overarching framework that has become our island's most comprehensive action plan ever created to achieve a sustainable future for our island. Governor Ige joined us last September 2020 when we formally adopted this framework. And now there are hundreds of action items and goals that we're moving forward. So there is one section of our action framework known as Thriving Natural Resources. And I see the Associate Director of our Sea Grant Program, Fran Castro, on the call with us today. She's actually the co-chair of that Thriving Natural Resources group. And the Guam Restoration of Watersheds fits in as one of the goals to achieve these UN SDGs, number 13, 14, and 15, which are climate action, life below water, and life on land. So this is one of our major local action projects in order to achieve global impact. So here I'll start with phase 1 of the GROW initiative that started when I was a graduate student there at the University of Hawaii at the Koala Marine Laboratory. I was working under Dr. Bob Richmond, who used to be the Marine Lab Director here at the University of Guam for many years. So he allowed me to go home and start a watershed restoration project for my doctoral research. And this is how we got started with the community project. And it was called the Humatic Project, starting at Fua Bay, where our ancestors tell us our civilization began. We are committed to reviving the once fruitful watersheds, vibrant coral reefs, and abundant fisheries of Guam. So it was a really special place to first start working on watershed restoration, because this is a place called Fua Bay, where according to the ancient stories of the island, that the first humans emerged from that rock, Fua Rock. So this is how the concern began in this village. There were fishermen that noticed they weren't catching the same size and quality of fish as they used to. And they reached out to their village mayor, who reached out to the University of Guam Marine Lab to find out what was happening to the fish in this village. And after a little bit of research and looking at the past development of the village, they found that this road in the 1970s, I'm sorry, in the late 1980s was torn down, rebuilt, and expanded. And during that construction process, they left these mounds of sediment uncovered for long periods of time. And in just a few weeks, when heavy rains came, it washed into the ocean where it flooded and smothered a lot of the coral reefs, killing them in just a short period of time. But there's sort of a chronic problem in this area because of badlands continually contributing to sediment in this area. This is a map of the southern half of the island. And 3.56% of the land cover are these areas called badlands, where all the topsoil has washed away. And it's just left with hard pan, or this area where it's really difficult for any vegetation to come back on its own. And so it only takes up 3.56 of the land cover, but it actually contributes to 50% of the total soil erosion for the southern part of the island. One of the causes of these badlands are wildland arson fires. So there's an unfortunate activity that some deer poachers engage in. They burn the hillsides in order to make it easier for them to catch deer. A few days after a fire, nice, soft, nutritious shoots of grass start to shoot up. The deer are attracted to those areas. They become easy targets because there's no vegetation there. And so that's why the poachers are engaging in this activity. So after the chronic series of fires, there are more badland areas like this that develop. The topsoil continues to wash away, and we're left with that hard pan area without nutrients. Another cause of badlands is irresponsible off-roading practices. So you can see how the land gets scarred pretty easily with continuous irresponsible off-roading. We also have a problem with feral ungulates. In Guam, we've got pigs and deer, don't have goats and sheep like some parts of Hawaii does, but pigs can make a serious impact, and we have them roaming the jungles quite a bit. So that's a huge cause of erosion as well. So in the GROW initiative, the first steps that we took for restoration interventions were sediment filter socks and trees. So if you take a look here, this is EPSCoR volunteers, EPSCoR members that had filled sediment filter socks with mulch in the piles behind them. And so you see this quite often around Honolulu. At least I remember that sediment filter socks were around almost every storm drain. You can see them off the sides of the freeway, but they also act as really great watershed restoration interventions. The volunteers installed them in eroding hillsides. We also planted thousands of trees in this first phase of GROW. And here's an example of one site that we picked, a hopelessly eroding area. Installed sediment filter socks and trees. And in less than a year, all the grass started to grow back. The trees were growing tall, and about 2 years later, some of the trees were over 30 feet tall. And at this point in this phase, we were using acacia trees, which are non-native trees to Guam, but they're also not invasive. It's one of the few species of trees that we know work in badland soils because they have nitrogen fixing bacteria in their roots. So this has been an established species that Guam Forestry has been using for, I think, way over 30 or 40 years now. Here's a closer look at how the sediment filter socks work. You can see the picture on the right. After a few months, the sediment piles behind the sock. It slows down the velocity of the water, and it allows revegetation, or it allows vegetation to reestablish itself. Here was one of our test sites, early test sites. There was trees, there were socks, and there were areas with socks and trees. And we compared it to a couple of reference sites in the same area where we didn't install any of these interventions. And after using a soil probe and poking the ground several thousand times to see how much sediment accumulated over time, we did a bunch of calculations. I'm not going to get into too many details in this, but you can check out our paper later if you're interested in how we arrived at some of these numbers. We also verified using soil profiles to make sure that our soil probes were taking accurate measurements. And we were able to come up with a number that these trees, about 200 trees and 100, I'm sorry, I'm trying to remember the feet of the socks, were about 200 feet of socks and several hundred trees. We were able to trap 112 tons of sediment in this site. So that was prevented from washing down into the Lost Fua River down below and out to Fua Bay. So the important thing about this study was that it was the first time that we were able to get an estimate of the trapping efficiency of trees and the trapping efficiency of sediment filter socks. So we had some previous data from Fua Bay where we had a lot of coral research happen, and there was an estimate that it would take a 75% reduction in sedimentation in order to revive the coral reefs there. And based on the trapping efficiency that we had determined with the trees and sediment filter socks, you could restore this watershed with 19 kilometers of sediment filter socks and 11,000 trees. So that was a great first step for figuring out phase 1 of the Guam Restoration of Watersheds initiative. Now, after doing that work in graduate school, I realized that was going to be a lot of work in at least my lifetime, that I was going to get tired of hiking 4 to 5 hours every day to go plant a few trees at a time. I didn't think that watershed restoration would be achieved in my lifetime. So we kept working on this. When I moved back home to Guam and officially started working at UOG Sea Grant, I was fortunate to be able to continue this work, and we started thinking about how can we get this watershed restoration done faster. And more people are working on this around the world now, dropping seed balls or directly planting trees from drones to create new forests. And so this is what we've been working on as we started phase 2. This is the ultimate goal, to get to that drone phase. But first we had to figure out what other kind of trees or plants would work in Guam in those badland soils. So I mentioned earlier that we had those non-native acacia trees, and we haven't had a solution for a local species. So we had a Sea Grant graduate student, Lawrence Waddell, who later went on to be a Knaus Fellow, and now she's back with us in Guam, working full-time as the Guam Green Growth Coordinator. But in her master's research, she created a badland simulation. So we had pallets of soil that was baked in a furnace to make sure that there were no contaminants or other seeds that might have been carried over from wherever she harvested that soil. And she planted several species of seeds with different applications, testing different rates of fertilization, testing whether scarification would work, scratching the seeds with like sandpaper, and trying different broadcast methods, direct application of the seeds or putting it into a seed ball. And she monitored how that affected germination, survival, and height over time. So she used compost, seeds, fertilizer, badland soils, and after using, I think, over 16,000 seeds and testing several species of sedges and shrubs, we found out that it was successful in germinating in badland soils. So now we have these new tools that have been added to our grow toolbox. Several species of sedges and shrubs that we know can actually grow in badland soils. This brings us to phase 3 of grow, where we had new partnerships from the USDA Conservation Innovation Grant, from the Guam Soil and Water Conservation Districts, and the US EPA. This is Teddy from our Sea Grant team, who is set up some plant nurseries at our Center for Island Sustainability, and also works at the Guam Forestry Department of Agriculture plant nursery, where he's planting thousands of seedlings every year. And he continues to get volunteers out in the field to plant these trees. We are also collecting seeds, like this one is a local species called dowk. And these new grants are allowing us to finally get to do the first tests of drone drops of these seeds. So just since last month, we bought this using a grant from the Soil and Water Conservation Districts, and we have the funding from the Conservation Innovation Grant to put these two projects together. And we have, since last month, dropped 15,000 seeds. So this is a really early phase that we're figuring out how to use the drone and how to make it the most effective. And Guam has 2 seasons. It's dry season right now from January through June, and from July through December, it's rainy season. So we're doing preparation work right now to figure out the best use of the most efficient use of the drone, so that in July, when the rains come, we'll be a lot more effective in growing these seeds. So a lot of testing will have to go in, but we're almost at that point later this year where we hope that the drone will allow us to do a lot more effective work, and we'll be able to replace some of those man hours from hiking up the mountains to getting more drones and speeding up this process to restore our watersheds and our native forests and improve, of course, the health of the coral reefs downstream. And this is also part of this phase of GROW. We have another grant from the US EPA. I mentioned Fran Castro, our Associate Director of Sea Grant, is on the call, and she is leading this project with a faculty member down at the University of Guam Marine Lab. And they are working on a project that complements all of the GROW work by developing a framework to assess ridge to reef ecosystem health in Guam. So the main thing that they're doing is trying to understand the nitrogen discharge patterns and dynamics for Guam EPA regulations. And they're taking measurements or taking samples from rivers at over 20 different sites in the southern half of Guam. And they're also applying for another grant to expand this work to the northern sites of the island, hopefully later this year or next year. So there's Teddy, the same guy that leads the tree planting. He's helping the water collection sites around the island. And we merge these data sets and hopefully make our watershed restoration work a lot more effective. And now we are getting ready to begin phase 4 of the GROW initiative, we have just learned that we received a USDA landscape scale restoration grant, and that will allow us to continue the GROW initiative. And so what it adds to our program now is that we'll be able to do things like create fire breaks. And this will help us address that program that I mentioned earlier in the presentation, that we have deer poachers burning the hillsides in order to make it easier for them to catch deer. With the capacity to add fire breaks in partnership with our Guam Forestry Division, then we'll be able to protect these restoration sites a little better. A couple of years ago, we worked with the off-roading community on a pledge program to conduct responsible off-roading. And it turns out that these have become really great partners for getting our supplies, trees, mulch, fertilizers into hard to reach places. So if a drone can't carry everything to a place that we need to get to, then our off-roading partners are really helping in our watershed restoration efforts. So we're hoping that this pledge program will continue to expand through the education efforts, and we can have less degraded areas. They do practices like tread lightly is the pledge, and they're switching off different trails and incorporating things like sediment filter socks and trees on trails that have been denuded, and we're trying to restore some of those areas. So we're excited for the continued partnership with some of these off-roading groups that will be allowed under the new landscape restoration grant. Another thing that we do is a lot of watershed educational outreach. So of course, this has been on pause a little bit since the pandemic started, but we often take large groups to the top of the watershed where they can see sources of erosion. Then we hike to the middle where we see how that erosion flows down through the watershed and the rivers. And finally hike down to the bay where they can see how the entire watershed connects. And if we don't have enough trees to plant at any one time, we make these things that look quite a bit like chocolate covered macadamia nuts there in Hawaii, but these are actually seed balls in the form of seed sling stones. So it's an ancient Chamorro or Guam practice in Guam, making sling stones, but we are making it now with a different purpose. Instead of hunting or community protection, they are now being used for restoration. So we make thousands of these a year and also throw them into the watershed. And same concept as the drone drops of these seed balls. We're also working on some capacity building projects with our National Science Foundation grants. So we have a new $10 million alliance with NSF Includes, working with the Virgin Islands and Puerto Rico and training over 585 students from all of the islands in high school, middle school, college, graduate students, and early career fellows. And a lot of the students that we have in Guam are working with research mentors on watershed restoration topics. And the high school students also participate in science fairs, and this helps them have a chance to go to the Intel International Science and Engineering Fair, and leads to scholarships and other career opportunities to continue along a STEM pathway. And the last thing I'd like to mention is that we have a Island Sustainability Conference coming up. This will be our 12th one, and I see Darren Lerner from University of Hawaii Sea Grant on the line, and we partner with him and others in Hawaii to put this conference on every year. So if you would like to learn more about GROW and other island topics, please join us virtually April 5th through the 9th, and registration will be up in the next week or two on our Center for Island Sustainability website. Okay, and that's my overview for the GROW initiative. Happy to take any of your questions if you have them.
Thank you so much. That was a great use of technology too. I really enjoyed your slides. And it was super inspiring to learn about all the amazing things you guys are doing down there. I know I have an initial question, if you don't mind. I'll just start off with that. Uh, what's the succession pattern of the shrubs and sedges that you're using? You know, will you have to go back and replant trees later on, or do you feel that those will be fine and trees will just naturally migrate in different areas?
It depends. I think our partners differ a little bit on priorities in this area. So, for example, our forestry division would like more native trees in the ground. So eventually, after acacia trees, the non-native trees, take hold of a forest, they go back in, clear those out, or thin out some of the acacias and plant some new native trees, because the acacias have fixed up the soil, added nutrients with soil litter and things like that, and it makes it possible for the native trees to grow. I think for our priority with the GROW initiative, it will be to cover exposed soil, cover the badlands as quickly as we can in order to slow down soil erosion and sedimentation on coral reefs. So I think a few of us will be working at it from different angles. I think, yeah, so exposed soil is my biggest concern. Thanks for that question, Mike.
Yeah, this is Tom. I was struck by how similar the problem is and some of the solutions you're applying to what's happening on the island of Kaho'olawe here in Hawaii. Are you familiar with some of the restoration efforts there? And have you tried to, learn from what's been going on in Kaho'olawe?
Yes, thanks for that question, Tom. Paul Joe Keel was on my committee, and I for my PhD, and I had one of his studies from Kaho'olawe referenced that after the removal of, I think, 25,000 goats, that they did some coral surveys in the years following, and they saw the resurrection of coral reefs. So with that example, another example of a moratorium of mangrove clearing in Palau, and another example in Kauai. You remember that Fluger clearing problem, and then there was a series of heavy wave action like a couple years following that. So once there's a little bit of time, if you stop the sedimentation from happening and you allow storms to clear out the sediment, then coral reef recovery can happen. So that's always been a big help in or inspiration for the work that we're doing. So if we could slow down the sedimentation, similar to other success stories around the world, then we think that we can get to success for the GROW project.
Great, thanks. I would call your attention to some of the work on Kaho'olawe that has to do with the methods and choice of species for revegetating areas of, that have been heavily eroded. So both gullies and, heavy gully erosion, and also surface erosion across the top of the island. About 2 meters of soil has been lost. And so it's a pretty challenging problem to get started with revegetation. So there might be some parallels there that would help you plan.
Thank you. I'll check that out. And that also reminds me of an example in, I think it's the Kohala Center on the Big Island, that they did these pretty cool innovative sediment check dams, where it's basically putting huge rocks and sticks and tarps over it, and they were able to plug up some of those massive gullies.
to comment. They really appreciated learning about these problems and innovative approaches that you're taking to address them. I was going to ask another question. Well, actually, sort of a comment. I thought it was really amazing how you partnered with the off-road community, and eventually they became allies, helping you achieve your goal, even though they started off as, you know, one of the major problems in creating these badlands. Can you tell me a little bit more about how you approach that community with outreach and how you kind of brought them together to work with you?
Sure, thanks for that question, Mike. So one of the things, there's this trifecta of things that all Sea Grant programs do, right? There's research, extension, and education. So in our extension efforts, the off-road community reached out to us because they were wondering how to incorporate some tree planting, because they thought that that might be a good activity to do. And also because they were worried about this perception from other members of the community that that there should be no off-roading at all. So how could there be sort of a balance, a way towards more environmental stewardship from groups like the off-roading community? So we agreed to help them explore this issue, and we facilitated a roundtable discussion with off-roading community groups. There's a few clubs on the island. We invited natural resource management agencies, and we invited property owners from areas where off-roaders like to go into. And so it was a really productive discussion. We held it at our School of Business here on campus. And I think it was the first time that our Sea Grant program got a back page cover in the newspaper in the sports section. It was pretty cool news that day that these different groups were coming together to work through these issues. And so that's how the idea of the pledge program developed, and to tread lightly. And so we continue to assist with that. And for, I think, 2 or 3 years now, we have gone to the big off-roading event of the year, which is in an off-road raceway park, a confined area where the off-roading community gets together. They have races. They have these Baja buggies that get shipped in for this big event every year. But that's one of our big outreach events with that group to make more people, to encourage more people to sign the pledge. So that's how we've worked on putting that together, and that work continues. The car dealership that sells Jeeps, for example, that they know that a lot of those go into off-roading areas. They encourage people to sign the pledge now whenever somebody takes one of those off the lot, for example. So we keep working in that area, but we have good partners willing to help convince their friends to be more responsible when they're going off-roading.
Thanks. That's great to hear about all the, I guess, all the spokes off that hub that are required for communicating and doing that outreach. We have another question. Can you talk more about how you are taking into consideration future climate change impacts, more or less rain or more heat, into the GROW project?
Yeah, thank you for that question, Maya. We're not quite there yet with the rain and heat impacts quite yet. We are trying to study the areas or the types of the species that will work, and the right applications with fertilizers, soils, mulches, and things of that nature. We do imagine that as the more that we do this and we see some seasonal shifts. So I mentioned earlier that we have just the dry season and the rainy season in Guam. I think that it's going to be changing a little bit between those months. So I think it will inform us on the planting times. Like we may not be able to plant starting in July anymore. We may have to begin moving that to August or September to ensure that our seed balls or the new tree seedlings survive. So there was that really great new study that came out from PICASC and the East-West Center, and we will be incorporating that into our future planning to consider all the climate change impacts. But yeah, not quite there yet for at least this next year, but hopefully in the next 2 years or phases of the project, we'll be able to think more clearly about that and have a better direction.
Have you had to worry about any extreme storms during the rainy season kind of washing away some of the work, or have you are still collecting data on that?
I'm sorry, Mike, I missed the first part.
Oh, I was asking for extreme weather events. Have most of the areas that you've replanted held, like, let's say you have
oh yes, yes, actually we've been lucky in the past, I'd say like 10-15 years. We haven't had major super typhoons, so we call them typhoons in Guam, not hurricanes, but they could be just as strong, sometimes way stronger, with over 100 to nearly 200 mile/hour winds. None of our restoration sites have been impacted by that. The more immediate threat are the fires. So we need to make sure that that our trees or restoration sites have at least 4 years between fires in order to take hold. So acacias, for example, have a little bit of fire resistance once they get bigger. But if they catch on fire before those 4 years, then it could wipe out the entire planting effort. So there are some educational outreach strategies that we have to address that, like making sure that kids or volunteers are coming from the village that we've planted in, so that they could be looking out for activities going on in that area.
Thanks. There's a question from Justin in the chat. He wants to know, has anyone looked at how recently burned land would take hold of your seed balls versus normal land?
No, we have not explored that yet, Justin. Good question. I guess we haven't dropped seed balls yet in recently burned land. We're looking for, we've been doing it in badlands that have been around for a while already. Yeah, that could be interesting, because there are some projects I've seen, like in Maui, in the West Maui priority watershed, where they have these fire kits. So basically they bank a lot of seeds, and after a fire or an event, they can go out and plant them right away. I know that was in discussion when I was working there at Hawaii DAR for a while. I'm not sure if that project ever took off, but that was something we were thinking about for Guam too. How could we have sort of a seed bank to get ready for after a fire and drop in and restore those areas right away?
Thanks, Austin.
We have another one that asks, are the restoration plots fenced?
Nope, we do not have that at the moment. Yeah, I can't, I'll have to try to remember what our earlier conversations were with USDA NRCS, but we haven't been doing fencing projects like is often done to keep ungulates out at restoration sites in Hawaii. Just hasn't been an option for us yet. But we're not really seeing damage from ungulates, if that's the reason for the fencing you're thinking about. We do have signs of pigs coming in and defecating under the shade of the new trees, but they haven't been tearing it too badly. I would say we have maybe a 15% or less loss of trees from deer that will just come in and bite the top off of a new tree seedling. But overall, the survivability seems pretty good. The 15,000 new seeds that we just planted with the drone since last month, we don't have any survival rates on that yet.
Thank you. Well, we're nearing the top of the hour. Does anyone else have any other questions for Dr. Shelton? Some more praise in the chat. Yeah. Thank you so much.
Yes, thank you all. And sorry, I'm a little rusty on my grow presentations. I've been talking about a lot of our other projects lately, but it's great to see some interest in grow and get to talk about it again.
We really appreciate you taking the time to come tell us more about the Grow Initiative, and it's also very good to make connections, you know, with our neighbors in Guam. So really appreciate it, and I also look forward to attending your seminar. You said that the registration will be available in a couple weeks. Is that correct?
Correct. I'll just put the conference website holder in the chat for you.
That'd be great.
So you can read about the theme, but the registration should be up in the next 2 weeks.
Thank you. Tom,
thank you, everybody.
Say anything before we depart?
Yeah, just thank you, Austin. Thanks very much for joining us. Nice to kind of meet you virtually anyway, and see about the really cool work you're doing in Guam. I look forward to meeting you in person. And yeah, just thanks again for joining us on your on a weekend for you.
Same here. Thank you so much, Tom.